Hello students, welcome to LUCID Study. Today I am going to explain you about structure of atoms. This structure of atom, it is chapter 6 in the 10th standard. Now see here till the 9th class. So what you have studied, what we discussed about the structure of atom means only we have discussed about the subatomic particles. Yes or no? But now see here in this chapter we are going to study some other various high standard concepts related to the structure of atom. Now let us enter into the chapter. See here, generally the structure of atom means it consists of a central nucleus. Yes or no? This nucleus it is spherical in shape. Now subatomic particles such as the protons and neutrons, they will be present in the nucleus, and electrons, they are going to revolve around the nucleus. Next one, see here, now in the case of this picture, so you can clearly see the neutrons and protons, they will be present in the nucleus, and electrons, they are going to revolve in the concentric orbits inside the atoms. Various scientists, they have put effort in order to explain the structure of atom. Already in our previous classes, we came to know about the subatomic particles. Yes or no? What are these subatomic particles? Protons, neutrons and electrons are the subatomic particles. See here, among these, electrons are the negatively charged subatomic particles, protons are the positively charged subatomic particles, and neutrons are the neutral subatomic particles. How do these subatomic particles, they are going to coexist in an electrically neutral atom all together? Okay, so if we are going to take the case of an atom of any element, this atom of any element, so what is the charge that is present on the atom of any element means it is the charge 0. See, atoms are electrically neutral, but if we are going to take the case of the protons, protons are the positively charged and electrons are the negatively charged species that are present in an atom. Now here what we can understand, see here how the arrangement will be there means protons and neutrons, they will be present inside the nucleus, and negatively charged electrons, they are going to revolve around the nucleus. The scientists such as the J.J. Thomson, Ernest Rutherford and the Niels Bohr, they contributed for the development of the atomic structure, and they proposed various atomic models. Next one, there is a activity 1 is there. Okay, what is that activity 1 means? On the basis of your previous knowledge, can you prepare the model of an atom? Already what happened till the 9th standard, we have studied about the atomic structure. Yes or no? Though the structure of an atom, it consists of a central nucleus will be there, and this nucleus, it consists of the protons and neutrons, and electrons, they are going to revolve around the nucleus in specific paths. Those paths, they are called as the orbits or the shells. Yes or no? Now next one, see here in this chapter, so we are going to discuss some more interesting concept about the structure of atom, and there are certain interesting questions are there. Okay, let us discuss about them. See, do all atoms have the same subatomic particles? Means what? All atoms, they will be having same kind of the subatomic particles. See, there are a total of 118 elements are there, and all these elements, they consist of the same kind of the subatomic particles, neutrons, electrons and protons, and their arrangement within the atom is also same. But what is been differing among the atoms means number of these subatomic particles are going to vary from one element to another element. Because of this reason, these elements, they will be having different properties. Now see here, Y is an atom of one element different from that of the atom of another element. We are having total 118 elements. So on what basis these atoms, they are differ from each other? Means, so just I said based upon the, see, as the number of subatomic particles they are different because of this reason. So here the atoms of different elements they are different. See here how are the electron distribution in the space of an atom. So already in our 9th class we have studied about the arrangement of electrons in an atom. Okay, these electrons they are present outside the nucleus, and electrons they will be present in the specific orbits, also called as the shells, yes or no, and these electrons they are going to revolve in the concentric orbits. Now in this manner the structure of atom it will be present. So all these kinds of the things we have studied till our 9th standard. Next one, here interesting concept is there. Okay, see whatever the questions we have discussed, okay, till now, and their explanation. So all those explanations they came by clearly understanding the nature of the particles. So first of all we have to understand the nature of the light. Okay, next one, see here what this light consists of. It also consists of the particles, yes or no, and we have to concentrate on various kinds of the flames. They will be having the various kinds of, here these different colors will be present in a certain flames. So when we are going to study about all those things and their characteristics, in the case of this image you can see about the nature of the light. What is the nature of the light? It is the dual nature. See the light it will be having the dual nature, means the light it will be having the particle nature as well as the wave nature. Now next thing, see here, now in this manner if we are going to study about the flames having the different colors, then we can understand some interesting concepts, okay, about the atomic structure. Next one, okay, let us discuss about the spectrum. Now what is this spectrum actually? So in order to understand the spectrum, see here, so generally during the rainy season what we can understand, see what we can observe means the formation of the rainbow can be observed during the rainy season, yes or no. Just after the completion of the rain we can see the rainbow. Now see here, in order to understand the spectrum we have to observe the formation of the rainbows. How many colors are there in a rainbow? See here, a rainbow it consists of the 7 colors. And what are those colors? All those 7 colors, so they can be called in short as the VIBGR. See here, violet, indigo, blue, green, yellow, orange and red color, yes or no. Starting from the violet towards the R, starting from the V to R, there will be a change in the wavelength. We are going to discuss in our further sessions. Now you can find the colors spreading continuously, and the intensity of each color varies from one point to another point. What we are having here VIBGR is there. Each color it will be having different intensity. Okay, see their intensity will be different and each color it is going to spread continuously. Next one, see here wave nature of the light. So this light has the dual properties. Light has the particle nature as well as the wave nature. First let us discuss about the wave nature of the light. Now for example, see here there is a, okay, water is there in a stagnant pond. Next one, if we are going to throw any stone, so in a stagnant pond, then what will happen? See, we can clearly observe the formation of the ripples, and see how these ripples they are going to travel means, for example, a stone is going to fall here. Now from this place and towards the periphery, from the center to the periphery, so the waves they are going to travel in the same manner. So what we can observe, whenever we are going to create any disturbance in the surface of water, we can see the waves, yes or no. Now similar to kind of the waves of the light, okay, means that wave nature, and see here the waves that are going to produce in a pond, they will be of same kind. In the same manner, now concentrate on the sound waves. See here, whenever sound waves are being generated, so from a drum, so then we can see the sound waves. So the nature of the sound waves and the waves that are being produced in a pond means on the surface of the water, they will be of same kind. Okay, you can see in this manner the waves are going to produce. Next one, in the same way. So till now what we have discussed about the waves that are generated in on the surface of a water and waves that are being generated from a drum. Yes or no? So we have discussed about the sound waves also. So similar to those waves, what happened? So we are having the electromagnetic waves are present. These electromagnetic waves, they are going to be produced by the electrical charge. See, see here what is being written here. See, whenever an electrical charge it is going to vibrate, then what will happen? So there is a generation of electromagnetic waves. In the case of this picture, you can clearly observe the electromagnetic waves. They are going to come from the electron. Whenever electric charge vibrates, that leads to the generation of electromagnetic waves, and these electromagnetic waves, they will be having the two fields, one electrical field, and because of the electrical field there will be a generation of the magnetic field also. What do you mean by the vibration? Vibrate means move back and forth. Next one, there is one question is there. Okay, how do the vibrating electrical and magnetic fields around the charge become a wave that travel through the space? So now to answer this question, so we have to clearly understand. Now try to recall the picture. From a particle means from an electrically charged particle, so there will be a generation of the both electrical and magnetic fields. A vibrating electrical charge, generally it creates a change in the electrical field. So first of all, there will be a change in the electrical field can be seen, and because of this change in the electrical field, it is going to generate the change in the magnetic field, and this process it will be continuous. So it will be continuous means what? So continuously the electrical field and magnetic field, they will be generated. Their direction will be in this manner. See, the electrical field and magnetic field, they are going to be generated in a right angle direction to the propagation of the wave. Means if the wave is propagated from here to here, then we can see the generation of the electrical field and generation of the magnetic field, they will be perpendicular with each other. Now see here, take the case of the visible light. So visible light means what? So whatever the electromagnetic radiation that can be seen by our human naked eye, it is called as the visible light. But see, whatever the light that is coming from the sunlight, it will be having the some other kind of the radiations also apart from the visible light. This visible light, actually it is an electromagnetic wave, and here the speed of the light, it is symbolized by the small c, and whose value is 3 into 10 to the power of 8 meter per second. So these kinds of the values we have to remember, because at the end of the chapter, so there will be some simple questions will be there, or the mathematical calculations will be there. Now next is, what are the characteristics of an electromagnetic wave? So this electromagnetic wave, it will be having a characteristic spectrum. Means what? Different kinds of the radiations, they will be present, so across the spectrum of the electromagnetic waves. In the case of this image, you can clearly observe, see, this is an electromagnetic wave. What happened? There is a particle will be there at that end. Now this is the direction of the wave propagation. Now in this manner, a wave, it is going to propagate from here to here. Now then what will happen? The electrical charge will be there, so it is going to produce the electrical field. and there will be a production of the magnetic field. So just now as I said, the electrical field as well as this magnetic field, they will be present perpendicular to each other. Means how this electrical field is present? Electrical field is present here in this manner and the magnetic field is present in this manner. Means see here, these two are present at right angles with each other. Means the 90 degrees will be there. There is one more concept is there, that is about the wavelength. Wavelength is nothing but what? The distance between these two peaks is called as the wavelength. Next one, here also you can clearly understand, if this is the direction of the wave, here this is the electrical field and it is the magnetic field. The electrical field, it will be present in this manner and the magnetic field, it will be right angle with the electrical field. Next one, try to understand. Okay, see now here, try to see the waves that are going to be generated in an ocean. So in this, now in this image you can see the waves that are being generated in an ocean. Next one, electromagnetic energy means whatever the light that is coming from the sunlight. Okay, so this electromagnetic energy is traveling through vacuum, and this energy, it is going to behave in a similar manner to that of the waves that are going to generate in the ocean water. Means whatever the light that is coming from the sun, so this light, it will be having the wave nature and it will be having the particle nature also. Like same as that of the ocean waves, electromagnetic energy, it will be characterized by there are two characteristic things will be there. So in this first one is the wavelength. Wavelength is symbolized by the lambda. Wavelength is symbolized by lambda and frequency is symbolized by the nu. So this is the nu symbol. Okay, nu means it will be in this manner and wavelength means lambda. Now this wavelength as well as nu frequency, they are the characteristic of an electromagnetic wave, and see, similar to that of the ocean waves, electromagnetic waves, they are going to produce means they will be having the wavelength and frequency. Let us discuss about the wavelength and frequency. First of all, what do you mean by wavelength? See, as I said earlier, wavelength is symbolized by the lambda. Now this wavelength is nothing but the wave is the distance from one peak to the next peak. Means what? So this is the first peak. Okay, so here you can see this is the one peak of the wave, this is the second peak of the wave. The distance between the two peaks of the wave is called as the wavelength. See, in the case of this first image, what you can see, the distance between the two peaks is less, means short wavelength. Here the distance between the two peaks is high, means the long wavelength. Now there is one more term is there, that is nothing but what? Frequency. Yes or no? What do you mean by frequency? Means the number of waves that are going to pass through a particular distance in a unit time. The frequency, it can be defined in this manner. So the number of wave peaks that passes by a given point in a unit time. Means, for example, take the case of only this much distance or a 10 centimeter distance. Now in this 10 centimeter distance, what happened in the case of the first wave? So there more number of waves are passing. Now here less number of waves are passing. That means what? This is a high frequency wave and this is a low frequency wave. Now see here, take the case of the units. The units of the frequency are the reciprocal of the seconds. Means what? Per second, 1 by second. It can be also written as per second in this manner. Next one, see this wavelength and frequency. So both are related, but see here how they are related means, so this wavelength and frequency, they are inversely proportional. See, wavelength is inversely proportional to that of the frequency, or we can write in this manner also. So, C is nothing but the velocity of the light is equals to the frequency into wavelength.